Okay, so today we're going to do section 1.3 and 1.4, and you're going to learn about measuring segments and angles and classifying angles. So the first thing we're going to learn about is distance or length, and they pretty much mean the same thing. It's how far apart 2 points are from each other. And if they're asking us to find the distance of like AB, we just put the two letters without any symbol above it. So this means the distance between A and B, or the length of the segment AB. So here, this means find the length of AC. So on a number line, if we want to find the distance, we can either count from A to C. So we would count, this is 1, 2, 3. So the length of AC is 3. The other way you can do is you can subtract the two coordinates, which are the numbers at that point, and you always do the absolute value, which means it must be positive. So for this, I would do the absolute value of negative 3 minus 0, which is equal to 3, because negative 3 minus 0 is negative 3, and the absolute value of negative 3 is 3. The order doesn't matter, so you could also have done 0 minus negative 3, and you'd also get 3. So for DE, same thing. If you look at it, the distance, if you count, is 1, but you could also do the absolute value of 3 minus 2, which is equal to 1. Again, the order does not matter. So if we do BD, I have negative 1 and 2. So if I do the absolute value, I do negative 1 minus 2, which is the absolute value of negative 3. So that's equal to 3. And you could check it by counting. This is 1, 2, 3 from BD. And then BC is the last one. So from B to C, it's the absolute value of 0 minus negative 1, which is equal to the absolute value of 1, which is 1. Okay, and just remember, these bars mean absolute value, which means you make the number positive. So two segments with the same length are called congruent. And the symbol for congruent is this. It's an equal sign with it's called a tilde, a squiggle line over it. And pretty much just remember that congruent means things are equal. And to mark two segments congruent, so if these two segments have the same length, we put a tick mark on them. So if they have the same number of tick marks, that means they're congruent. So like I could do this one, and I would put 2 tick marks on this one to show that these are congruent. So if this is AB and this is CD, I would say AB is congruent to CD. Okay, so AB's length is the same as CD. That's what we're saying. So on this, we said AC is congruent to DE. So if AC is 15, what is DE? So congruent, if the two segments are congruent, that means the measure, so the length of AC must equal the length of DE, which means DE must equal 15, because they have to be the same length, so they both must be 15. So now we're getting into algebra. So they're going to give us an expression, which is like 2x minus 3 and 3x minus 7, and they're going to ask us to find the value of x. So on this, they said AC is congruent to DE. So again, that means that pretty much the length of AC is equal to DE. And on here, they're saying AC is 2x minus 3 and DE is 3x minus 7. So if AC is equal to DE, then I'm going to replace AC with the expression that is equal to it. So I'm going to replace it with 2x minus 3, and I'm going to replace DE with 3x minus 7. So since they're equal, I'm setting these two things equal to each other. And then we have to go back to Algebra 1 to solve it. So I'm going to put it over here to solve it. So in order to solve this, we want to get all the x's on one side of the equal sign and all the numbers on the other side. So I'm going to first move the x's. I'm going to move the smaller x to make it easier. So I'm going to move the 2x by subtracting 2x from both sides. And you always line it up with the other x terms. So these add to 0, so I'm going to cross them off to show they add to 0. And 3x minus 2x is equal to 1x. So then I have negative 3 is equal to x minus 7. And now I want to get the x by itself, so I need to move the number over. So we do the opposite operation, so I'm going to add 7 to both sides. And if I do that, I get 4 is equal to x. And you can write it as x equals 4 if you want. So the answer to this is x equals 4. And when they ask these, we want to always find x as a number. So example 3 says AC is congruent to DE. And if AC is 4x plus 2 and DE is 6x minus 4, find the value of x and then the length of AC. So before we can find AC, and if they want the length, they just want the number, how long is it as a number, we always have to find x first. So again, I know that AC is equal to DE because this symbol, congruent, means equal. And then I'm going to replace AC with 4x plus 2. And I'm going to set it equal to 6x minus 4 because they're congruent, they must be equal. And then I'm going to solve it again. So I first have to get the x's on the same side. So I'm going to subtract the smaller x from both sides. So this adds to 0, so I'm left with 2 here. 6x minus 4x is 2x, and then I bring down the minus 4. Now I need to get the 2x by itself, so I need to move the number over. So I'm going to add 4, because that's the opposite, to both sides. And I get 6 is equal to 2x, because these add to 0. And then to get x by itself, we have to do the opposite of the operation, which is multiplication here. So I'm going to divide both sides by 2, and then I get 3 equals x, or you can write it as x equals 3. So that's the first part, this one. Now I still need to find AC. So once I know x, it's pretty easy. I go to what AC is. So AC is equal to 4x plus 2. And I replace the x with the number I found it to be, which is 3. And then I just solve it. So I do 4 times 3 is 12, and then I add 2, which is 14. So the length of AC is 14. And since we're saying length, you just put AC with no symbols over it. So the next thing we're going to learn is the segment addition postulate. So what the segment addition postulate says, if there's 3 points, A, B, and C, which are collinear, and B is between A and C, then we know that we can add AB plus BC, and that's going to give us the whole segment, which is AC. So for example, on this one, they said AC, which is this entire segment, is 16, and BC is 5. So this is obviously not drawn to scale. The numbers don't match up with the lengths, which will happen a lot in geometry. So don't go by looks, just go by the markings or what you know. So we want to find AB. So since AC is the whole thing, and it's 16 and BC is 5, to find AB, we can subtract them. We could do 16 minus 5, which is 11. The other way you can think about it is you can call the missing piece x, and then we can do what we said here. So AB, which is x, plus BC, which is 5, is equal to the whole thing AC, which is 16. And then if you want to solve it, you subtract 5 from both sides again, and you get x to be 11, and x is AB, so that would be 11. So number 6. So I'm going to erase what we had here to relabel my diagram. You always want to label your diagram. It helps. So AB, this part, is 19. AC, so the whole thing is 23. I want to find BC. So again, BC is a part of it. So what we do is we take the entire thing, which is 23, and we subtract the part that we know, which is 19, to find the other part, and that would give us 23 minus 19 is 4. So BC would be 4. Again, you can call this x, and you could do 19 plus x is equal to 23, and then subtract 19 again, and you would get x to be 4, and x represents BC. So on number 7, now we're going to get variables again. So we have x's, and it's going to be similar. So I get AB is 3x, BC is 5x, and then the whole thing is 8. So when you do this, we're going to use this postulate, okay? B is between A and C, so we add the two parts. We know that AB plus BC is equal to AC. So that means AB is 3x, BC is 5x, and AC is equal to 8. Now on this one, 3x and 5x are on the same side, so they're like terms, and we can add them. So that is equal to 8x, and that's equal to 8. And then to get x by itself, we divide by 8, and x is equal to 1. Okay, the last one and the most challenging one on this one, if I erase what we had, we get AB is 3 times the quantity x plus 7. BC is 2 times the quantity x minus 3, and AC is equal to 50. Find x, and then we need to do one extra thing, which is find AB. So again, I'm going to use the postulate above. I'm going to add the two pieces, so AB and BC, and it's going to equal the entire thing, which is AC. So I'm going to replace each part with what it's equal to above. So 3 times x plus 7 plus 2 times x minus 3 is equal to, I'm going to change this to 50. And then we have to solve it. So whenever you have parentheses and a number in front, the first thing we do is distribute. When you distribute, you multiply the number by both. So 3 times x is 3x. I keep the sign in the middle, and 3 times 7 is 21. Then I'm going to do the same thing with the 2. I get 2 times x, which is 2x, and then 2 times negative 3, which is minus 6, is equal to 50. Then 3x and 2x are like terms, and 21 and negative 6 are like terms because they're on the same side of the equal sign, so I'm going to add them together. 3x plus 2x is 5x, and then I'm going to add 21 and minus 6. So if I add those, I get 15 is equal to 50, and now I solve it like we did before. You always move the constant first, the number first, so I'm going to subtract 15 from both sides, and I get 35. 5x is equal to 35, and then I'm going to divide 5 because I'm multiplying, and then x is 7. And then always make sure you answer the question. So we need to find AB. AB is equal to 3 times x plus 7. So instead of the x, I'm going to put the 7. And then just remember order of operations. So I'm going to do parentheses first, which gives me 14. And then 3 times 14 gives me 42. So AB is equal to 42. Then we have midpoint. Okay, so midpoint, we talked about it a little bit last class, but we know that midpoint is a point that divides a segment into two equal parts. Okay, and then if M is the midpoint of line segment AB, then we know a few things. We know that AM is equal to MB. We know that if I do 2 times AM, it's equal to AB. And the third thing we know is if I take a half of AB, it's equal to AM. So if I explain this a little bit more, right? If I have two segments, or if I have one segment, sorry, AB, and M is the middle, how we generally show it is we put the tick marks, or they'll tell you M is the midpoint. If it's just looks like it's in the middle, that's not enough information. They either need to tell you it's the midpoint, or they need to show the tick marks like this to show that it's the midpoint. So in this case, we know that AM is congruent to MB, so their measures are equal. So AM is equal to MB. If they're equal, that means if I take AM and I double it, I would get the whole line, which is AB, which is part B is saying. And part C says if I take the whole segment AB and I divide it in half, I should get half of it, which is AM. And the same thing is true. If I take 1/2 of AB, the other one I should get is MB, because MB is half of the whole thing. And I could also do 2 times MB is equal to AB as well. So we're going to do a few practices with midpoint. So if M is the midpoint of AB, find X, AM, MB, and AB. It always helps to draw a picture. So I'm going to draw a segment AB, and I'm going to put M in the middle of it. And I'm going to show the tick marks so that I get used to it. And then I'm going to label my picture. So I have 9x minus 4 is AM, and 5x plus 20 is MB. And I know that they are equal because M is at the middle. So I'm going to set the two sections, the two parts, equal to each other, and then I'm going to solve it. And I'm going to solve this one a little bit faster, so if you need to review, just pause and then do it. Okay, and then the last step, I divided both sides by 4 and got 6. Now that's only the first part. Then to find AM, I'm going to plug 6 in for X for 9x minus 4. So I'm going to do 9 times 6 minus 4. So 9 times 6 is 54, minus 4 is 50. Now, automatically, we should know that MB is also 50 because they're equal, but you might want to check it to make sure that you solved your equation correctly or did this right. So if I do 5 times 6, I get 30, and if I add 20, I got 50. And then we want AB, so AB is these two pieces, which should be equal, which is 50 plus 50, which is equal to 100. You could also do 2 times 50 because AB is double one of them. Okay, and then number 2, similar. Same diagram. If AB is 2x plus 30, if I draw it down here, so the whole thing is 2x plus 30. And then MB is 3x minus 4. Okay, so if MB is 3x minus 4, and they don't tell me anything about AM, the only thing I know is that they're equal, so this is also 3x minus 4. And then we know that they have to be equal to the total, which is 2x plus 3. So if I think about it, it would be AB plus MB has to equal AB. So the two parts have to equal the entire thing. And I'm going to do AB is 2x plus 30, but because it's equal to MB, that's also 2x plus 30. And then I'm going to set it equal to AB. Oh, sorry, I did that wrong. Backtrack a second. Sorry, AB and MB are both 3x minus 4. So I'm going to write those in for both of them, and then I'm going to set it equal to 2x plus 30. Then I have to solve it. So again, add my like terms because they're on the same side. So 3x and 3x is 6x. Negative 4 and negative 4 is negative 8. Then I have to get all the x's on one side, so I'm going to subtract the smaller one, which is 2x, and I get 4x minus 8 is equal to 30. I'm going to add 8 to get the numbers on one side, so I get 4x is equal to 38. And then I'm going to do 38 divided by 4, and I get x to be 9.5. And then I'm going to plug it in to find all the stuff I just did. So AB is 2 times 9.5 plus 30, which is 49. Again, you can assume MB is 49, or you can check your math to make sure you did that correctly. Actually, 24.5. Okay, so what actually should happen, because I just said that wrong. Remember, AB is the whole thing, and MB is half of it. So MB should be half of AB, which is true. If you do 49 divided by 2, you get 24.5. So we did that correctly. And then we still need AM, which is also 24.5. And then we're just going to check and make sure we answered all of them. So we found AM, we found MB, and we found AB. Okay, so the next part is angles. So an angle is where two rays meet at an endpoint. And that endpoint is called a vertex, which is important. So make sure you know that word. And we can name an angle multiple ways. If there's a number in it, we can just name it with a number. So that's angle 2. We can name it by the vertex point, which is angle C, as long as there's only one angle with that name. Or you can name it with 3 letters. If you name it with 3 letters, the vertex has to be in the middle. So you kind of like trace. So I could name this angle ACM, or I could go the other way, angle MCA, but C must be in the middle. The vertex point must be in the middle. So congruent angles are angles with the same measure. And in an angle, that means the degrees are equal. So it has the same degrees. And so when we talk about the degrees of an angle, that's like the distance between the two rays. So that would be like 30 degrees. And if this one's also 30 degrees, the angles are congruent. The length of the rays does not matter since they go on forever. And to show angles are congruent, what we do is an arc. So we can do an arc like that. They might also, if they want to show 2 angles are congruent, do an arc with like a tick mark in it. Or 2 arcs, you can do 3 arcs. And sometimes the angles might not look congruent, but if they draw the same number of arcs, these angles, so like angle C would be congruent to angle A, even though they don't look like it, they both have 2 arcs. So by definition, they are congruent. Okay, so that's the symbol. They have the same number of arcs. So we have 4 types of angles. An acute angle measures less than 90 degrees. A right angle measures 90 degrees. Okay, and for a right angle, we draw a box. So when we want to show a right angle, unless they tell you in the directions or they put this box, you don't know it's a right angle. So you must have that symbol or they tell you it to know that it's a right angle. So then acute angle is less than 90, it looks smaller. An obtuse angle measures between 90 degrees and 180 degrees. And then a straight angle measures 180 degrees. So again, a obtuse angle looks bigger than 90, so an example would be like 130, and then a straight angle is 180 degrees. And we can do the same thing as we did for the segment addition with angles. You can add the two angles, the two parts of an angle, and get the whole angle. So angle AOB is this part. Angle BOC is this part. And that makes up the whole angle, which is AOC. So on this one, AOB is 45, BOC is 60. They want the measure of angle AOC. So just as a thing, if they write this like that, this means the measure of angle A. So the little M in front means measure. So in this one, to get the measure of angle AOC, I would add the two parts because I'm adding AOB plus BOC, and that would give me 105. On this one, we have BOC is 50, AOC is the whole thing, which is 130, find AOB, which I could call X. So there's two things you can do. If you know the whole thing in one part, to find the other one, you subtract. So I would do the entire thing minus the part, which gives me 80. And you can check it. 50 plus 80 gives me 130. The other thing is if you write the whole thing out, so the measure of angle AOB plus BOC is equal to the measure of angle AOC. AOB we don't know, so we can call it X. BOC is 50, so I replace that. AOC is 130, and then if you solve this, again, you subtract 50, and you get X to be 80. And then the last one has a little bit of algebra. So AOB is 6x plus 2. BOC is 4x minus 10. And then the entire thing is 52. Okay, so the two parts, AOB and BOC, I'm still using this. I add the two parts together, and I set it equal to the entire thing, which is 52. On the terms are on the same side, so I add my like terms. So 6x plus 4x is 10x. A positive 2 minus 10 is negative 8. Then I'm going to add 8 to both sides, so I get 10x is equal to 60, and then divide by 10, and x is 6. And then the second last example is an angle bisector. So if BD bisects angle ABC, then angle ABD, the measure of angle ABD, is equal to the measure of angle DBC. And so bisects means to cut in half. So make sure you write that down because it's important. So it means to cut in half or divide into two equal parts. Okay, so if I take BD and it bisects the angle, it divides it into two equal parts. So they said ABC. So if I trace that, ABC is the entire angle, is 46. And they said find ABD, and we know BD bisects, so that means ABD is half of 46. So I can take 46 and divide by 2 to get ABD, and that gives us 23. The second one, ABC is 52, so that again is the entire angle if I trace it. ABD is 2x minus 4. Okay, so there's two ways to do this. One way is you can double 2x minus 4, so this would also be 2x minus 4, and then set it equal to the whole angle, which is 52. So I could do 2 times 2x minus 4, because we need to multiply it by 2 to get the whole thing, is equal to 52. Then you'd have to distribute again, And then add the 8 to both sides, and you get 4x is equal to 60. And then if you divide, you get x to be 15. The other way you could do it is you can take 52 and divide it by 2 to get that each angle is 26, and then you can set 2x minus 4 equal to 26. And again, if you solve this, you get x to be 15. And then this one, ABC. So again, if we trace ABC, it's the whole angle, is 3x plus 12. ABD is 2x plus 4. Find x, and then also the measure of angle DBC. So this one, again, if it bisects, which they told us in the directions, these two parts are equal. So ABD and DBC are both 2x plus 4, and they have to equal to 3x plus 12. So you could write it as 2 times 2x plus 4 is equal to 3x plus 12. Or you could just do 2x plus 4 plus 2x plus 4 is equal to 3x plus 12. And so if I do this one on the left first, I distribute the 2. So I get 4x plus 8 is equal to 3x plus 12. I'm going to move the smaller x to the other side to get the x's on the same side. And then I'm going to subtract 8, and I get x to be 4. If I do this one, I add my like terms. So 2x plus 2x is 4x. 4 plus 4 is 8. So I get 3x plus 12. Now, these are the same because this should equal what 2 times 2x plus 4 is, which it does, and then you solve it the same way, and you would get x to be 4. And then to find angle DBC, the measure of it, I'm going to take DBC, okay, which they didn't tell me in the directions, but as we can see with our picture, DBC is the same as ABD, so that's also 2x plus 4, and I'm going to plug in 4 for it and then solve it. So 2 times 4 is 8, and 8 plus 4 is 12. So the measure of angle DBC is equal to 12. Okay, and then the last problem, and probably the most challenging one, it says find the value of x if x be a. So again, you trace the angle, and at the vertex, whatever angle you make, you put it in between there. So this is 4x plus 3. ABD. So if I trace that one, I start at A, I go to B, and then I go to D. I made this angle in here, which is 7x. And then the last one is XBC. So I start at X, I go to B, and I go to C. So that's the whole thing. So if it's the whole angle, I usually draw brackets like this and put it outside. So we need to make an equation. So we have 3 parts. So what that means is we have to add all 3 parts to get the entire angle. So we're missing B or DBC, but they have this arc, and we talked about it a little bit ago that the arc means the 2 pieces are equal. So DBC is whatever XBA is, which is 4x plus 3. So those 2 pieces are equal. So now I have all 3 pieces and the whole thing. So what we do is we add the 3 pieces and we set it equal to the entire thing. And then on this side, we combine our like terms because they're on the same side of the equal sign. So I have 4x and 7x and 4x. So I'm going to add all those numbers together. So 4 plus 4 plus 7 is 15x. And then I'm going to add my 2 numbers, which are 3 and 3 is 6. And I'm going to just write this the same. And then to get the x's on the same side, I subtract 15x from both sides. And I get 6 is equal to x minus 1. Add 1, and then x is equal to 7. Okay, so that's it for our section on 1.3 and 1.4.